In these examples, we're going to use graphs of derivatives to help us tell about the concavity of a function. Use the graph of the second derivative of the function f to determine where f, the graph we don't see, is concave up or down. So remember, that means we have to think about if f double prime is positive or negative. Then find any inflection points on the graph of f, again, the graph we don't see. Justify your answer. So remember, when I'm looking for where a function is concave up or down, I start with looking for where the second derivative equals 0 or does not exist. This is a graph of the second derivative. So where does this graph equal 0? Here and here. At two locations, x equals -3 and 2. Let's use those locations to make our number line. We'll put our intervals, and we'll talk about investigating the sign of the second derivative. -3 comes first, and then 2, and then our intervals go -∞ to -3, -3 to 2, and 2 to infinity. Now let's explore the sign of the second derivative. Because this is a graph of the second derivative, we're thinking about where is the second derivative above or below the x-axis. Above the x-axis is the positive sign, below the x-axis is the negative sign. So on the first interval before -3, the graph is above the x-axis, like it is again after +2. So in these two places, the second derivative is positive. Then we have the section where it's below the x-axis, where the second derivative is negative. Now, let's not look at that graph anymore because it might be misleading. Let's take our information now from our number line. We can conclude that because f double prime is positive on the first interval, that f is concave up on that interval. Middle interval, f will be concave down, and then the last interval, f is concave up. So let's list our conclusions. F is concave up on the interval -∞ to -3, and again from 2 to infinity, because the second derivative, f double prime, is greater than 0. Then f is concave down on the interval -3 to 2, because f double prime is negative, less than 0. Now we do have places where the concavity changes here, so f does have inflection points. Here the concavity changes, so that's the location of an inflection point, and here the concavity changes, so that's the location of an inflection point. So let's write that f has inflection points, -3, f of -3. Remember that they have to be ordered pairs. This is the x value, and because I don't have a function to plug in the x value, I'm going to show that I'm plugging it in with f of -3. The other inflection point is 2, f of 2, and then to justify my answer, I say because f double prime changes sign. Use the graph of the derivative of the function f to determine where f is concave up or down. Then find any inflection points on the graph of f. Justify your answer. This time we have a graph of f prime, but we still want to think that we're looking for where f is concave up or down by exploring the second derivative. And we think that we're going to start where the second derivative equals 0 or does not exist. That's going to happen when we're exploring the first derivative, where f prime changes from either increasing to decreasing or decreasing to increasing. That happens once on this graph right here, decreasing to increasing, and that's at -1. So we set up our number line with -1. Intervals, -∞ to -1, and then -1 to infinity. And now we explore the sign Or rather, we do want to explore the sign of f double prime, but we want to think about what f prime is doing. So at first, f prime is decreasing, then f prime is increasing. So that means f double prime is negative, and then f double prime is positive. What does that tell us about f? That first, f is concave down, then f is concave up. So here's how we'll write our answer. F is concave up on the interval -1 to infinity because f prime is increasing. Because we're given a graph of f prime, that's how we'll justify our answer. And then f is concave down on the interval -infinity to -1 because f prime is decreasing. Finally, because there's a change in concavity, we can say that f has an inflection point, and that's going to be at the x value -1. Plugging it into the function, we get f of -1. Since we don't have an actual function to plug into, that's going to have to be good enough. And we justify by saying because f prime changes from decreasing to increasing. Thanks for watching.